Hello, everybody. I hope you're having a beautiful day or evening, whichever it is for any of you. Um, I was just dabbling in a little bit of science and physics, and I wanted to talk about an interesting topic. Now, like I said, a lot of these things that I say or speak out into the world, I'm letting you know now, are theories and hypotheses. So, all in all, unless it's concrete, actually, I don't even like using that word because everything that we know is based on our perception. So, actually, everything that we know is based on our view of reality. So, nothing is an absolute truth if you really think about it. But beyond that, I want to talk about the third and fourth dimension and the different dimensions that people talk about in terms of vision. So, I just wanted to play this video for a little bit and then I want to talk a little bit more about it.
Dimension look like? Christopher Nolan's Interstellar has one of the best movie representations of the fourth dimension. One simple way to attempt this is to see what happens when you mathematically render a square into the fourth dimension. A square is a two-dimensional shape. In the third dimension, you get a cube. And in the fourth dimension, you get a tesseract.
Okay. Now, right here, I wanted to show you guys something. What he did was, all he basically did was made a smaller cube within that cube, and so we could see inside the cube now. So what I'm going to say right now is he didn't just go to the fourth dimension in terms of vision. What he did was he made it transparent. He gained the ability to see through walls, so to speak. So the reason I'm bringing that up is because there's actually another video talking about this one real quick.
If you were a four-dimensional creature...
So he's going to explain 2D, and then I'm going to reiterate why some of the things that we think right now may be false, and we need to open our minds to new ideas.
You could see through the walls in front of you right now. Let me explain with an example. So let's say that we have these two people, Josh and Molly, and they both exist in the second dimension. Can Josh currently see Molly from where he is standing right now? The simple answer is no, and the reason why is because there's a wall currently in front of Josh obstructing his view. Now I'll ask you the same question about Molly. Can Molly currently see Josh from where she is standing? And the answer for Molly is also no, because these two-dimensional creatures have their view obstructed by this wall between them. But then this begs the question, how come we can see both of them right now? Well, the reason why is because we are three-dimensional.
Not true. I'm going to explain something to you real quick. If they're on a two-dimensional plane, and we're hypothetically saying that they can't see each other because there's a black line drawn in the middle. If you remember, this is a 2D plane. So if I were to draw a full black wall in front of both of them right now, which I could do, but I'm not going to. So if I could draw a wall in front of both of them, you wouldn't be able to see them. If you turned your phone to the left or right or your piece of paper, you still wouldn't be able to see them. You wouldn't be able to see a two-dimensional creature because the wall would be obstructing it just like how this wall is. What a lot of people do when they go to lower and higher dimensions is what they're doing is they're gaining the ability to see things that they wouldn't normally be able to see, transparency. So that's like saying, if I stood next to a window, somebody outside now has 4D vision because they can see me on the inside. That's kind of a bad correlation actually. But actually, it's not a bad correlation because just like the person can see me outside of the window still, Josh and Molly, in theory, can still see you and me because they're looking directly at us if we're taking that approach. So what I like to throw out there is that we actually have full dimensional view outside of the 180-degree space. And I'm going to explain something right now. I go as far as to say we see in all three dimensions. And in terms of vision right now, that's all there is to see. This is a 3D space, 3D space time. And so I guess what I'm saying is I don't think that it goes higher than 3 dimensions in terms of visual view. So when people make different shapes and objects and then go, if you could see on the inside of those objects, that's not. The crazy thing behind that is the way the mind works. We perceived that the other side of the object is there. So if I see a 3D cube, the rest of my mind fills in the blanks. I actually can't see the full view of the 3D cube. I like to throw something else out there. This might be a little weird for some people if this is the first time you're hearing it. The eyes, I know how I said we see in full dimensional view because of what the brain fills in. But if you actually pay attention to what the eyes see, we only see in 2D. we only see as if there's a picture drawn in front of us, and because of light, shading, and spacing, things appear to have space between them. But if you were to actually look at a table and you were to pay attention to the table, that same table could be drawn. That's how the eyes work. We're seeing photons after hitting an object go into our eyes, showing us the basic point of where that object is. But we don't see the distance, we perceive the distance, because in actuality, everything that's in front of you is in 2D, minus the spacing, the shading, and your mind filling in the blanks. Just like if you were watching a television or looking at a picture, if you took away the shading and the spacing, theoretically in your mind, and just looked at that thing like a picture, everything is like that. We see basically in picture view. So I just wanted to put that out there. I think there is only 3 dimensions of view. And I mean, other people could argue and create different shapes and stuff. But in terms of actual vision, just like these 2D people on this phone screen, I could block them with the wall and then I wouldn't be able to see them anymore. Then I would perceive them on the other side of the wall in my mind. So, you know, the brain more or less is actually 3D and the eyes view in 2D because the brain has spatial recognition. If we couldn't perceive space, then it would just look like a picture. And we can feel that there's space when we move our hands and arms and stuff. But the interesting fact is, if you actually, if you're far away from an object, you realize the closer you get, the bigger the object will get. Well, if it's like a cartoon or a picture screen, what would actually be happening is it'd be like it's drawn there, and the closer you get, the closer the drawing comes towards you, or the bigger the drawing becomes. You know, so I'm not saying our eyes are computer screens. I'm not saying, I'm just throwing theories out there. I like the idea of thinking about that, like, actually the theory that we only see like in 2D, like a screen or something, but because of, like I said, the shading and the spacing, we perceive it to be 3D. So, I'm going to do a few more scientific videos in the future, possibly. I've just been leaning a lot more towards science and the physical nature of things. I really like learning about, here's another weird theory that I wanted to throw out there. There are magnets. If you put 2 magnets together, positive and positive, then they repel each other. But if you put positive with negative together, then they attract each other. So give me a second and I'm gonna pull up a video real quick and show you guys something. Okay, sorry about that. So now I had a theory about quarks and protons, and I wanted to talk about it real quick. So the strong nuclear force and gravitational force and magnetic force, there's 4 basic fundamental forces that hold the universe together. I believe it's the weak force, gravitational force, strong nuclear force, and then there's a 4th one. But that's besides the point. I want to talk about magnetic force, electromagnetic force, and strong nuclear force. So I'm about to play a video for you real quick and show you how this magnet levitates.
Proved device created by Hamdi Ukar and his associates. Hamdi is the scientist who pioneered the discovery of this new effect and first described how it works with mathematical precision using classical mechanics. If you just have 2 repelling magnets, it's inherently unstable and it's impossible to perfectly balance each other without causing one of the magnets to flip. This is called Earnshaw's theorem. You can't have a stable...
Now see, when you notice when you pair a magnet right, minus with plus, then it attaches, but plus and plus, it breaks apart or repels each other. Now, I wanted to show you guys something real quick when dealing with quarks. Now, the major prognosis is that neutrons are neutral, but in actuality, which they are, because if you pay attention to quarks, quarks are the subatomic particles inside of protons and neutrons, and they're called quarks. And then there's gluons also, but I'm going to talk about the quarks right now. So If you pay attention to the neutron, it has one up quark which has a plus 2/3 charge, and it has two down quarks which has negative 1/3 charge. So the two negative 1/3 charges cancel out the up quarks, so to speak, and so that's why they call it neutral. Well, if you look at a proton, you have two ups, which is plus 2/3, and then a down, which is 1/3, negative 1/3, and so it's a positively charged particle, or yeah, a proton is. So what you guys just witnessed just now when the guy was rotating the magnets, what you were seeing was when dealing with magnetic force, the North Pole pushes energy out, so to speak. I'm going to simplify it down. It basically pushes energy out while the South end does the opposite. It pulls it in, so to speak. And that's where you get the repellum and attraction force. On a side note with this real quick, I just wanted to throw a little computery sci-fi out here. This is the sci-fi part. Now, when dealing with binary, you have 1 and 0, you have charges and whatnot. And those charges basically are the basics when dealing with computing and whatnot. So I just had a little idea, just like how this magnet looks. If you had a system that shot out maybe +1 and then had a -1, and that system, what you would be seeing is, instead of, I call it trinary instead of binary, you would have 1, 0, and then -1. And so then what you would do is you would have energy that force pushes out, but because of how the law of attraction works, when it pushes out, it goes at a half circle, which I think is like pi or something like that, the diameter of circle. When you push it out, it goes at a half circle and circles back around and come in. So if you push out an energy of +2, but then had an attraction or a vacuum at the back of it of -2, what you'd be doing is you'd be pushing energy out, and then it would create a field and come back in, two half circles from the points that it pushed out, almost like magnetic fields with the Earth. Okay, so back to the regularly scheduled programming. You saw how those magnets were spinning really fast, and so when the magnet is spinning, what's happening is you have an instance where it repels, and then once it's on the other side, it attracts again. But it has to be doing it at a certain speed, and the magnet has to be so close, or else it won't work. And when dealing with the strong force, that's how protons work. If they get too close to each other, what happens is they start to lose energy because it takes more energy because of the amount of force it takes to push those two positives together. But once you take them away, they start to gain energy again, coming back together. So what I'm going to explain real quick is in order to fully put those two particles together, it would take an infinite amount of energy. Because the closer they get, the more energy you need, just like how light speed travel is. And so you would have to continuously up the energy in order to keep those two protons together. So then you have the strong nuclear force. They can't spread apart too far, and they can't come too close. So what I'm suggesting is, I actually believe protons can, and this deals with fusion too, I believe protons can be attracted to each other until they lose a certain amount of energy. What do I mean? If this proton, which is what quarks do, if these quarks are spinning at the speed of light, what you would have are pulses of waves in terms of change of where the poles are and how the attraction's going. And so if the quarks inside of a proton are spinning at the speed of light, what you would have is you would have another particle that's spinning at the speed of light. Those two particles, when the two up particles meets the down particle on another proton, they would temporarily be attracted to each other. But when those two up particles from the proton meets the up particles from the proton again, what would happen is they will repel each other, creating a constant wave or flux, which would actually explain gravitational waves. Because then you add an electron to that equation, the electron is going to have a orbit based on the magnetic waves that are flowing from the proton, which explains electron orbits. And electrons by nature are electrically charged. And so they would also be attracted by the proton, but at some point repelled by the proton when the down quark meets it. So let's say the same as dealing with the proton and the neutron. Ultimately, the neutron would have a stronger attraction to protons because it has more down quarks, but it also would have a violent repulsion when meeting the up quarks, if that makes sense. And so they would constantly vibrate. And the only way to get them closer to have that kind of energy be locked in place would you'd have to have high types of energy, like fusion, which would explain why hydrogen, when they slam together, create deuterium, but let off a gamma ray. What you're doing is, just like how I said earlier, once those two particles slam together and get close enough, you have a release of a massive amount of energy that was built up before, because the energy that it took to push those together will then be released in the form of gamma rays. So it can get really complicated, but I really like math, but I also know that math can be infinite, but I am also not infinite. And so I like to try to find more real world applications to compare them to. So that would really, electromagnetism when dealing with magnets would really explain a lot that's going on in the quantum world.
One of the magnets to flip. This is called Earnshaw's theorem. You can't have a stable equilibrium with a static magnetic field. But an interesting thing happens when you take a magnet on its end and spin it really fast, around 10,000 RPM. A second magnet will actually be attracted to it, but then...
And then when looking at that describes orbit. So you look at the sun. The sun has a big blob around it, but that's the different layers of its atmosphere. On the inside is a core. That core is doing fusion and has a lot of built up energy. It's causing a massive spin. That spin, or all the positive energy in the middle, is creating a pole, or we would call ours the atmosphere on Earth. For the sun, we would call it the hydrogen wall. You can look these terms up. There's a hydrogen wall that protects us from plasma coming in. Well, that same magnetic field, what would it do? Other large amounts of mass with fields around them, we'll say the planets with cores, would be attracted to it. But at the same time, because they have a core, a positive charge, they would also be repelled by it. And so you then hit a sweet spot where they orbit the sun and follow it, which would actually really make sense with the quantum world. And so I just wanted to put that out there. You know, there's a lot of different speculation and theories about how quantum dynamics work. And so I just wanted to put that out. I honestly believe a lot of people don't agree with me with this, and certainly some people attack me. Like I said, it's a theory. I believe gravitational waves are literally just electric magnetic pulses and magnetic waves. I believe so. Like, I'll take the Earth. I believe everybody has a charge. All matter has a charge, whether it be positive, negative, whatever. And I believe that's why a lot of items, the more mass you have, the more density you have, the heavier items are. Because in actuality, we're not seeing heaviness. We're seeing another lump of mass being pulled with full force towards the core. But we have a crust and the mantle and all that, so we're protected from flying down into the core. But that's just my theory. I believe, honestly, we're looking at it in terms of weights and stuff, but I honestly think it's the pull of one object to another object. And so since we all have a positive and a negative, we all carry electrons, I believe we are being pulled towards the center of the Earth. Like I said, that's just a theory. A lot of people say gravity is its own force and all this other stuff. We haven't really figured out what gravity is. But I believe the micro and the macro all work hand in hand. They say the quantum world works on a bunch of different rules, but I don't think we can perceive a lot of the quantum world. What we're doing is we're receiving data from a lot of computers and programs and AI and algorithms that are programmed to deal with data when it receives it. Well, the problem with that is there could be all types of errors and or phenomena that have nothing to do, like CERN, when they blast particles together. There could be a lot of phenomena in the quantum world we don't understand. I believe in string theory. I believe there could be a lot of other things at play when dealing with these particles and stuff. So they're already talking about quarks spin at the speed of light and stuff, but we're charging these particles up and causing them to smash. So that could account for a lot of these particles. It doesn't really explain them in rest. So, Another thing, I talk about relativity a lot. The reason I say we will never have an absolute truth is because nothing will weigh the same on any different planet. Nothing will ever move at the same speed. If you drop an item towards the earth, the item is moving twice because the item, what it's really doing is it's actually moving once, but appears to move twice. The item through space time is moving twice. It's moving forward through time and the earth moves and it rotates, but it's also falling down because of gravity. Now, the thing is, the reason we don't plunge into the earth, like we'll say we don't weigh 10,000 pounds, is because of the type of magnetic field that we have on earth. It's not that strong, so we don't get plunged inside like a black hole. One of my final theories I want to put out there, and this has to do with density and matter. I don't think black holes are what we perceive them to be. I think a black hole is like a neutron star, but stupid more dense. I'm gonna go a bit further. I think if a neutron star is comprised of neutrons, I believe, and it's just a theory, I believe that black holes are proton stars. And the reason I say that is because the thing with a black hole is that if you have an item with ultimate density or an item with ultimate pull or gravity, what's going to happen is if you touch that item, let's say we'll put a marble in a water tank, and this marble has a stupid hard attraction or a magnetic pull. Now, if you put that item in water and touch that item, it's not going to attract to you. And I'm going to explain what's happening. It's because of water pressure. What's happening is there's a tons and tons and tons of water molecules that are on top of the surface of that item. So what's happening is those water molecules are already blocking like, I'll give you an example. If you look at a black hole, there's a bunch of items around it. They're spinning around it. We'll call it the accretion disk, like the galaxy, the Milky Way. Well, why doesn't all the matter just smack into the black hole at once? Because there's levels of gravity the further you get out. So the gravity at the black hole is super stupid massive. But if you go out further and further, the gravitational waves are less intense, because I believe that's because of all the matter that's in front of it. So with that being said, I believe the blackness of a black hole is all of the particles that are actually inside of the black hole. I don't believe any of them can escape, but I actually don't believe things can get sucked into a black hole the way we think they do. And I believe that's why all the matter is in a disk around the black hole, because if that weren't the case, everything would just get sucked in from every angle. And what I believe is happening is the gravitational spin from the violent spin from that, which is creating an electromagnetic spin, is affecting the matter around it, which causes it to spin with it, like how the sun's rotation causes the earth to rotate. It's really deep. So basically, I believe a black hole is like so packed with matter because of the violent magnetic pull on it from all different areas, like the gravitational pull. I believe it's so violent that you're seeing that much matter being lumped on top of each other. I don't think a black hole is an infinite point in the middle. I don't believe that. I believe it's super massive and it's gravitational. The magnetic pull from the chemical reaction inside from the matter that's inside is causing it to crush inward the matter that it already has compressed inside. So, I could be wrong. Black holes do engulf each other in other items, but even when a black hole consumes a star, it doesn't just suck the whole star in at once. What it does is the gas surrounds it and creates a accretion disk. So, yeah, those are just a couple of theories I want to throw out there. Like I said, I'm not a rocket scientist, so just throwing some stuff out there. If you like it, cool. If not, double check my facts and enjoy. Hey, just to reiterate on some of that stuff, like the gravitational waves, um, when I was talking about the density and the matter, what I was saying was, like, take the Earth's crust right outside the core. What's happening is the Earth's crust is so dense and thick because of how That's what basically density is, how many particles you can pack into a closer point, so to speak. So if you look at a basketball that's hollow, it's not dense because it only has air in it. It might be dense with air pressure, but it's not dense with a lot of heavy matter. But then let's say you take a metal steel ball, that entire ball that's comprised of 100% steel, it's going to be heavier. It's going to be like, because it has a lot of matter with it's really dense. So back to the black hole. What I'm suggesting is that black holes, there may be a core or an area around the black hole, which then creates an atmosphere, which is the entire black circle we see. And then I believe when the light hits it, it instantly gets pulled down. If I believe anything that gets close enough to a black hole to touch it is going to get caught in the secretion disk around the closest point. And what I believe is happening is I believe matter is slowly going into the black hole from the increased spin. So it'll be extremely hot and there'd be a magnetic pull, a strong gravitational pull. So I believe everything closest to the black hole in succession to each other all gets pulled in matter by matter. Black holes grow. And so I just think it's a really, really, really dense object. Just like how, think of it this way also. Like this doesn't have anything to do with gravity, but to help conceptualize how things can come down to the core, come down to the equator. Like take Earth, for example. It's much warmer down in the equator because it's around the center mass. You see what I'm saying? So that's why I believe the gravitational pull is so strong, so it creates a wave around it like that, which is the secretion disk. And I believe everything on top is super ultra packed matter that's already been, I'll say, fused into the matter of the black hole. And ironically enough, they say black holes radiate, they release energy. And most things that radiate is losing energy the closer it gets. Is it not? Like when two protons or two fast moving particles fuse, they lose a massive amount of power. They lose a massive amount of energy because they got closer. So I believe that's also what's happening with the radiation that leaves a black hole. The positive energy, the energy is being sucked in super tight. And also, this is just a theory, another theory, and I have to do more research on how neutrons decay into protons. But when dealing with a neutron star, I actually understand now, since they're considered neutral, why they'd be easier to pack together. Because in actuality, if you look at a neutron, the quarks inside would be a down, down, and a up. Well, the up is 2/3 and the two downs are 1/3. So what you would basically have, the closer you got together, if it did lose spin, or even if it spinned even more tightly, just like the magnet example I showed earlier, how the more energy you spend, if it gets closer and closer, with higher energy, it'll take more energy, but it gets closer and closer. So in terms of neutron stars, that would make sense. The down quarks, or the downside of neutron, would be really, really attracted to the positive side of a neutron, because technically they're both 2/3 in one direction. It goes up 2/3 and down 1/3 twice. And so that would explain why neutron can get so close and packed together, because even if it does spin, the attraction from the plus 2/3 to the down 2/3 is causing a tighter orbit versus the opposite attraction of how a proton will work, because it's more of a positively charged particle, so it spends more energy pushing away. Versus a neutron, it would spend less energy pushing away, and I actually take less energy to come together. So this final theory, I don't know exactly how neutrons decay. I believe in order for a neutron to decay, it has to lose a neutrino, or something has to happen to it. I'd have to look it up. But when it decays, it becomes a proton again. So if you have a super powerful neutron star with a ton of mass, nova, technically, depending on the parameters, what could be happening is they could really be all turning into protons. You could have billions and billions of positively charged neutrons decaying into protons at once. And because of the gravitational pull and charge of that type of explosion, it would massively, violently push all those protons together, which then would have actually a nova would probably create the energy involved to push protons together. So if a massive amount of protons in a neutron star, or if a massive amount of neutrons in a proton star decayed at the point of explosion, that same energy would cause them to push together and cause a massive strong force, which would probably be that infinite amount of energy I was talking about to get neutrons to fuse together. I mean, protons to fuse together. So I just wanted to throw that last part out there. Like I said, I'm not a rocket scientist. I just like to explain some things sometimes with some of these theories. I'm really interested in black holes also, so you know what I mean? It's pretty cool. So enjoy yourselves. If you got any theories you like to throw out there, I also do well with explaining like a lot of religious stuff. Like I don't really believe in like magic, but like I said, there's a spectrum of the universe I can't even see. There's a lot more waves than light waves, and just like how light waves carry data, photons into the eye so we can see things, radio waves and other waves, you know, send waves into our ears to perceive things by the brain. There's a whole realm of things I cannot see, hear, or feel. It's like air particles. I only interact with them in my lungs in other various ways, but and wind. So, you know, I just like to explore and talk about things and learn and grow. If 7 billion people came together, not fusing together to become one, but in diversity to learn a bunch of different new views of the world, then the world would kaleidoscope. We would turn into not a prison, but a prism. And so when light hits us, we turn into a rainbow.